Hello everyone, today we're going to be looking at reference angles and talking about this unit circle I've been referring to in class. So, reference angles are a thing on its own, but they really do help with the unit circle and just helping you kind of see the relationship between the angles that really do get repeated all across the unit circle. So, reference angles are angles in standard position, as all angles that we're looking at are, and it is formed by the terminal side and the x-axis. So we're not worrying about the y-axis, we're just worrying about that x-axis. And it's going to be, like if we're in the second quadrant, it's going to be, how much more is it until we reach that 180 degrees or pi? In the third quadrant, it's going to be how much past the 180 degrees or pi. And then in the fourth quadrant, we're going to be looking at, okay, how much more is it until that 360? Because again, we just want to look at that x-axis. We don't want to worry about the y-axis, just that x-axis and the relationship really between, 180 and 0 or 2 pi. My first quadrant does not need any reference angles because it is just the angle itself. Reference angles are always acute, and they are positive. We will never consider this like a negative angle, even though if we're going to be graphing it, it would be negative, but we're just looking at, hey, what's my reference angle? How can I refer to this in the first quadrant? And then all of my trig functions and everything else, like my coordinates, would be based off of that point and that angle. If you're a big fan of formulas, you can always think about it this way, 180 degrees minus my angle, or pi minus my angle minus 180, but I like to just think about, okay, we're looking at that 180, we're either going, how much more, how much less, or with the 360, just as a conceptual kind of idea. So, say I wanted to find the reference angle for 330. First thing I'd recommend doing, figure out which quadrant you're in. If I was going to quickly sketch 330, well, I'm past 270. I'm not quite at 360, so I am going to be somewhere here in the fourth quadrant. And exactly how much? Well, since this is 360 and I'm at 330, how many more degrees is it until 360? And that's just 30. So 30 degrees is my reference angle. Find the reference angle for negative 5 pi over 6. Now, though the radians might seem intimidating, the nice thing, your reference angles for your radians are always predictable. If I have any sort of denominator of 4, that's a reference angle of 45. If I have a reference angle for anything that it has a pi over 3, it's going to be 60 degrees. And then for any pi over 6, my reference angle is just 30. And this comes from just, if I take 180 divided by 4, I get 45. And for all of my fractions, it's just always going to work out that it's just going to be that little bit more to get 1 pi, or that little bit, how much over 1 pi have I gone? The denominator is always going to stay the same. So, my reference angle, I can think of the fact that this is going to be, okay, it's a little bit less than 1 full pi, since negative 5, 6 is a little bit less than negative 1. Well, a little bit greater than negative 1, I should say. And so we would be in the second quadrant, but because we have a nice radian, we know automatically that our reference angle is just 30 degrees. We will practice more in class, but just trying to give you the overview. So the unit circle. It's called the unit circle because our radius is 1, which is just considered like the unit. So, thinking back to our ratios for any sort of angle, if my radius is 1, well, then I have y over 1, and y over 1 is just y. And then similarly here for the cosecant, 1 over y would just be 1 over y. Cosine, I've got x over r. My radius again is 1, so it's just x. Secant would then be 1 over x. And then tangent and cotangent had nothing to do with our radius, so those are still our same, y over x and x over y. So long as you know these guys, you don't really have to memorize anything new for the unit circle. It's just a matter that your radius is 1. So for the sine at a given point on our unit circle, we're just looking at the y value because our radius is already taken care of with that 1. So this is going to look very overwhelming, but I promise it won't be. If you are a big memorizer, memorizing's your thing, you can go ahead and memorize this whole chart and be set. Overall, we're pretty much looking at our 45, 45, 90, our 30, 60, 90 within our first quadrant. So say I was looking at the 30, 60, 90 that's right here. I know my radius is 1. My relationship within a 30, 60, 90 is that across from 30 is half of whatever's here, so I have 1/2. And then across from the 60 is whatever this is times root 3, so I've got the root 3 over 2. So the sine of 30, opposite of hypotenuse, 1/2. Cosine of 30, root 3 over 2 over 1, which would just be root 3 over 2. So really we are just kind of deconstructing that unit circle over and over and over again. However, we're going to do the trig hand jive in class. I'll record a screencast on that as well to help you kind of quote-unquote memorize these, but in a manner that isn't going to be entirely mind-numbing and just kind of helps you remember things, I think, more easily than having to, okay, tangent of 30, root 3 over 3, and just kind of always spitting out that way. Now this should look familiar. We looked at this a little bit in class. What we are going to be mainly focusing on for this guy is helping us translate what we know within this first quadrant to the whole rest of the unit circle. So if I'm looking at my first quadrant, I see that all functions are positive. Here, all my sine functions are positive. Here, all my tangent positive. And here, all my cosine positive. So ASTC, in order of the quadrants, helps us kind of remember, all right, well, it's positive there. So that way, once you know how everything in the first quadrant, you can very easily translate it to the other ones. Now, ASTC seems a little strange. I like to help you guys remember it by thinking of all Santas taking cookies. So I'll probably keep that little graphic and any sort of assessment that has to do with this kind of stuff. Like I said, you can memorize this whole unit circle thing. I'd rather show you, get you really down with the first quadrant. The quadrantals would be pretty easy just based off the fact that our radius is 1. And then once you know the first quadrant well, it's very easy to, okay, well, in the second quadrant, my x values are negative. Third quadrant, my y values are negative, as well as my x values, and then just kind of going from there. So we'll practice with the trig hand jive. Unless you're a big fan of memorization, then go for it. But we'll look at that in class, and like I said, I'll also have a separate screencast for the trig hand jive, which just kind of helps you get the first quadrant down quickly and easily, and it's just kind of a neat little trick. So we'll look at that in class, and I'll see you then.